Hi, I am a student of Kharkiv National University of Radio Electronics. My name is Dmytro Nazarenko, and today I'm going to present an article about investigation of the deep learning approaches to classify emotions in texts, together with Iryna Afanasieva, Nataliia Golian, and Vira Golian. Today, there are a lot of information around us, a lot of textual information, and this data can be useful for us and for following researchers. The content of text can be a useful resource for text mining to uncover a variety of issues that can be done with texts. For example, we can check how users are reacting for a certain video, or how they are reacting for the certain product, and plan trying to predict their reaction on the following products and posts and other stuff. So the emotion component of text could be very helpful for us in a real world usage. The emotion recognition approaches in sentiment analysis are divided in several groups. The first group is keyword-based approaches, and the keyword-based approach relies on finding occurrences of keywords in a given text and assign an emotion label based on the detected keyword. The next one is a classical learning-based approach, and it's based on the standard machine learning approaches such as SVM. SVM, this is the most used classification algorithm in the reviewed papers, which is a supervised machine learning algorithm, and it helps us to classify emotion by the certain group. But the latest researches and the latest implementation are mostly based on the deep learning approaches. That includes neural network approaches and other stuff that were studied and that were researched in these 10 years. So in this paper we are investigating the state of the art deep learning approaches for recognition emotions in textual data. The first one is the first solution for the emotion recognition was proposed by Wang at 2016, and he used a convolutional neural network approach, CNN, and the tests that were used for testing the network was based on the dataset RAN and the NLPCC 2014 emotion analysis in Chinese Weibo text. So the texts were mostly Chinese, and the result was 60.05 points F score metric. The next solution was done by Meisheri and Day at 2018, and they were used pre-trained embedding with two parallel architectures based on BiLSTM approach. The embedding matrix was generated using emoji2vec, GLOF, and character level embeddings. And these two architectures outputs were combined and fed into two fully connected networks. And in the same eval 2018 competition, their model came in second position among the teams, and the result was 58.2 by Jakarta accuracy. next investigated solution was made by Seiditabarey at 2019, and they were used fast text as embedding, as word embedding, and BiGRU approach as a neural network baseline. The F-score for this approach was 63.2 on Crowdflower dataset. So, based on these researches, we decide to investigate the most state-of-the-art approaches, and these approaches were embeddings and neural network baseline. As baseline approaches, we use BiLSTM, BiGRU, and CNN, and as embedding we decided to use GLOVE, fast text, and word-to-vec approach. Let's take a look on the architecture more deeply. The BiLSTM approach is based on the recurrent neural network approach, and it has a similar control flow. It processes the data passing on information as it propagates forward. The core concept of LSTMs are the cell state and its various gates. The cell state acts as a transport highway that transfers relative information all the way down the sequence chain. So the LSTM is consisted of cells that contains the forget gate, input gate, output gate. Forget gate decides what information should be forgotten. Input gate, it is the new information. The output gate is the hidden state that will be used in the next cell, on the next state. So the BiLSTM is the upgrade of the common LSTM. It is a sequence of processing models that consists of two LSTMs, one of which takes input in one direction and the other in the other. So that help us to work with textual data, so we can take a look not only in forward way but in the backward too. The BiGRU has almost the same architecture as BiLSTM, but the architecture of the BiGRUs of the gated recurrent unit cell is a little different, and it is consisted of update gate and reset gate. The functions is pretty similar. The functions of these gates are pretty similar as BiLSTM gates. The next one was CNN, Convolution Neural Network, and it was first developed in the field of neural network image processing. But in our case, we are using it for textual data, and so we are gonna to have it for feature extractions, and we'll use the convolution and poolings. These two operations will be very helpful for us for textual usage. So after all preparations, we set the baselines and the embeddings that we will work with. The embeddings, as we said before, it is word-to-vec, GLOVE, fast text, and also we are gonna to use sentiment word embedding. We train sentiment word embedding by ourselves, and the main point is to work with words, not only like semantic data, but like sentiment data. That means that two words could be close to each other in meaning of word-to-vec approach if their sentiments are quite closely, and if not, then these two words will be quite far away from each other. Then the next one is datasets. The big issue is to find the appropriate datasets for this task, because we need to clearly understand which neural network works better, and in this way we need to collect more data than just one dataset. So we decided to work with 5 datasets, and that these datasets have different data, different labels, and different structure. So the first one is a main dataset that is built on social media content on Twitter, and it has 4 labels: anger, joy, sadness, and fear, and it contains more than 7,000 tweets. The next one is easier dataset, and it is built on collecting questionnaires answered by people with different cultural backgrounds. The labels are joy, fear, anger, sadness, disgust, shame, and guilt, and there are over 6,000 samples. The next one is Stack Overflow dataset, and it is built on Stack Overflow questions and answers that was collected by crowdsourcing, and it contains more than 24,000 posts and 6 labels: life, fear, joy, sadness, anger, surprise. Crowdflower, that dataset, it's one of the biggest datasets that we have, and it have pretty nice labeled data. It has 30,000 tweets that are labeled in 5 emotions, and these tweets are annotated via crowdsourcing. The last one is daily dialogues dataset, that is high quality multi-term dialogue dataset. The dialogues in the dataset reflect our daily communication way, and there are more than 30,000 dialogues. Each dialogues were splitted by speeches, and in total we have 100,000 speeches, and each speech is labeled by 7 emotions. So we have 5 dataset and 12 unique emotion in summary. The train in test step that we performed, it was building models for each type of embedding, for each type of approach. So we are using the tuning hyperparameters to train our models. For optimizer we use Adam, and for loss function we are using categorical cross entropy. As a final metric we are using F1 score. We are firstly training, and after that testing on the test dataset. So we are splitting each of the dataset on train and test data. The split coefficient is equal to 0.2. So we have for BiLSTM results that are shown to us that Word2Vec is the best approach to work with balanced dataset like ECR and Crowdflower. It has the best performance counting by F1 score. But for BiLSTM approach, we also need to take a look on glove embedding, and glove embedding works better with sparse datasets like MINT daily dialogues. And let's go next, and the next one is CNN. CNN works worse than BiLSTM. All embeddings show worse performance than we have in BiLSTM approach. But for CNN, the best one is sentiment embedding. And let's go, the next one is a BiGRU. For the BiGRU, the best performance was made by glove embedding, and it has the best performance for each type of the dataset, and for BiGRU it is the best choice. So at final results, to conclude, we investigated that BiLSTM and Word2Vec in the neural network architecture provides better results on balanced datasets like ECR and Crowdflower that has pretty good balance of each type of emotion classes. But for sparse dataset, the best performance scores was shown by BiGRU with pre-trained glove embedding. So if the dataset have very unbalanced classes, like we have joy labeled, the data labeled by happy in 10 times more than sadness, then it is better approach is to use BiGRU with glove. But for the real life problems, for the real life issues, the best one is BiLSTM and Word2Vec, because most data are pretty balanced on the network, on the YouTube, on the different internet resources. We have a lot of comments, and we have different opinions, not only strictly happiness or strictly sadness, and that's why it should be used BiLSTM and Word2Vec. So for now that's it, and thanks for watching.